Hi guys. Okay, all of our small little lessons were adding up to this big lesson. Adding and subtracting fractions with unlike denominators. That's different than what you did last year in 5th grade. Last year in 5th grade, you did add and subtract fractions, only the denominators were exactly the same. So all you had to do was concentrate on the numerators. This year, we got to concentrate on both. Okay, here's our reasoning. Remember me telling you this in class, you can add and subtract things in unlike. These two fractions are not alike. We're going to have to find a way to make them alike. You just probably watched a video that talked about least common multiple. We're going to use the least common multiple to find a new denominator that works well with both fractions. Okay? Now, 9 and 3. These are the numbers that you need to concentrate on. You need to concentrate on your denominators because these two numbers have to be the same before you can move on. Since 9 and 3 are somewhat small numbers, I'm just going to make a list of multiples. I'm not going to use my factor trees. One, because 3 is prime, and that just doesn't work. 9 is small, so we're just going to list them out. Here are my multiples of 3. 3, 6, 9, 12, 15, 18. Here are my multiples of 9. 9, 18, and I already see that they've got 9 in common. They also have 18 in common. But remember, I want the least common multiple. I want the smallest number they have in common. That would be 9. So now I know that my LCM, or my least common multiple, is 9. I'm going to write that right here. So that tells me that I want my denominator to be 9. Here, 2 9, my denominator is already 9. So I don't have to do anything to this fraction. But here, my denominator is not 9. I need to change it. Right now it's 3. I want it to be 9. What could I do to the 3 to make it become a 9? I know you're thinking, multiply by 3, and you're correct. Remember that golden fraction rule. Whatever you do to the bottom, you've got to do to the top. Whatever you do to the top, you have to do to the bottom. So because I multiplied the denominator by 3, I'm also going to multiply the numerator by 3 as well. So now I can replace this 1/3 with 3/9 because they're the same. They're equivalent. They mean exactly the same value. So my new addition problem is 2 9 plus 3 9. Now this looks like one of your 5th grade fraction problems, and all I have to do is concentrate on the numerators. 2 plus 3, is 5. And of course, the denominators never change. 5 9 is your answer. Okay, we're going to do one more with adding, and then we'll do some subtracting. I'm going to erase this. Hope you had a chance to get it down. And don't worry, we're going to do the exact same thing again. All right, again, I've got 2 small fractions, 5/6 and 2/5. Because 5 and 6 are smaller numbers, I'm not going to use my factor tree. I'm going to use just the listing out the multiples, counting by 6 and counting by 5 until I find something that they have in common. So here's my list of 6. 6, 12, 18, 24, 30, 36. Here's my list of 5s. 5, 10, 15, 20, 25, 30, and I believe we found the smallest number that 6 and 5 have in common. So for this problem, my least common multiple is 30. That tells me that I'd like for my denominators to also be 30. So I'm going to take one fraction at a time. First, 5 6. Right now my denominator is a 6. I'd like for it to be 30. How do I get from 6 to 30? What can I do to the 6 to make it equal 30? If you said multiply by 5, you're correct. And I'm also going to do the same thing in the numerator because that's the rule. 5 times 5 is 25. Now I'm going to take care of my other fraction. It doesn't look like I want it to look right now either. 2/5. Right now I have a 5 in the denominator. I'd like for it to be a 30. So what can I do to the 5 to make it equal to 30? If you said multiply by 6, you're correct. And of course, I also want to do the same thing to the numerator. 2 times 6 is 12. So now I can rewrite my addition problem using these two equivalent fractions. I've got 25 30 plus 12 30. I'm just going to erase all this so I can rewrite my problem. And now, all I have to do is add. 25 plus 12 is 37. And my denominator never changed. But I know that some of y'all are looking at my answer. 37 over 30. That won't work. That is our answer, yes. We did add that correctly. However, we cannot leave the fraction as an improper fraction. So here's another lesson from the past. We are going to divide. Top goes inside, bottom goes outside, and we're going to divide. 30 goes into 37 once. 1 times 30 is 30. I'm going to subtract. My remainder is 7. Now remember how we put that together? The number that sits on top, that's the whole number. 7, the remainder, is the numerator, and the denominator never changes. That's my answer. Remember, don't stop here. When it's an improper fraction, go ahead and change it to a mixed number. All right, I'm going to erase all of this. We're going to go to the other side, and we're going to look at what some subtraction problems look like. Remember, the process doesn't change. You're still going to need to find the least common multiple if you're looking at two different denominators. My first subtraction problem is 3/4 minus 1/6. I am looking at two different denominators, so I'm going to need to change that. 4 and 6 are small numbers, so I'm just going to make a list. 4, 8, 12, do one more, 16, oh, one more, 18. Here's my list of 6. 6, 12, 18. So they've got 12 in common, 18 in common, and if I were to keep going, they'd probably have some more numbers in common. But remember, we only want the smallest. And so my LCM, or least common multiple, is going to be 12. That means right now, I'm looking at 3/4. There's a 4 in the denominator. I'd like for it to be 12. What do I do to 4 to make it equal to 12? If you said multiply by 3, you'd be correct. And of course, I want to do the same thing in the numerator. 3/4 is also equal to 9/12. Let's do the other fraction. 1/6. Right now there's a 6 in the denominator. I'd like for it to be a 12. And I know you're thinking, multiply by 2, so that's what I'm going to do. In the denominator and the numerator. 1/6 is also equivalent to 2/12. So I'm going to rewrite using my brand new fractions with the same denominator. 9/12 minus 2/12 is equal to 7/12. And this would be my answer. So 3/4 minus 1/6 is equal to 7/12. Okay, we've got one more. 17. Now for this particular problem, I am going to use my factor trees. 10 and 8 are smaller numbers. But we're just going to use our factor tree because we haven't done it yet. So I need to concentrate only on the denominator. So when I do my factor trees, it's going to be over the numbers in the denominator. Like 10 and 8. 5 times 2. Both of those are prime. 4 times 2. 2 is prime, but the 4 isn't. 2 times 2. Now, I'm going to make my two different number sentences and stack them on top of each other. 5 times 2, that's 10. 2 times 2 times 2, that's 8. Remember, LCM, or least common multiple, means everybody gets to go. We're just going to look for the pairs and couples first. Those two 2's are going to come together to make 1 and 2. Now all I have are singles, but I'm going to make sure that all my singles get to go. Here's a single, it gets to go. Here's a single, it gets to go. And I'm going to multiply all these numbers together. 2 times 2 is 4, times 2 is 8, times 5 is 40. My LCM, or least common multiple, is 40. That tells me right now I've got a 10 in the denominator. I want it to be 40. I've got an 8 in the denominator. I want it to be 40. So now I'm going to erase all this so we can change our fractions and give them brand new denominators. Remember, our least common multiple was 40. We got to make sure our denominators are 40. So I've got 7/10. But I'd like for my denominator to be 40. I know you're guessing or you're thinking, multiply by 4, you'll get to 40. And you're correct. So I'm going to do that in the denominator and the numerator. 7 times 4 is 28. I've got one more fraction to change. Because that denominator is 8. Remember, we want it to be 40. I know you're thinking, multiply by 5, so that's what I'm going to do, both in the denominator and the numerator. 1/8 is equivalent to 5 over 40. So now I can subtract. I've got two new fractions with the same denominator. 28 minus 5 is 23. And the denominator never changes. That's my answer. 7/10 minus 1/8 is 23 over 40. Thanks for watching, guys. We'll be practicing this soon. See you later.